for this practice problem, we have a car driving down the road at a speed of 80 feet per second. And then it starts to decelerate at a rate of 16 feet per square second. And it says, how many feet does the car travel before it stops? So right here I have this little car, and we are ultimately going to be looking for a position function. So the initial position of this car before it starts to decelerate, we're going to say is 0 feet. So at time 0, this car has gone 0 feet. And the initial velocity of this car at time 0 is 80 miles per hour. And we're told that right after this piece, so as time starts to increase from 0, this car is decelerating at a rate of decelerating at 16 feet per square second. So we have an acceleration function of -16. So what we're going to do is we're going to use that acceleration function. We're going to find a velocity function. And notice that this says how many feet does the car travel before it stops. So we know that at this stopping point, the velocity is going to be 0. So we're going to figure out what value of t will give us a velocity of 0. And then we're going to use that value that we find in the position function, and we're going to calculate that to find our ultimate answer. So here's the plan. So we're going to start with this acceleration function. And I want you to notice that, remember that if we take the derivative of the velocity function, we'll get the acceleration function. Therefore, the velocity function is going to be the integral of the acceleration function. So the velocity function is going to be the integral of -16 dt, which is -16t plus c. And we can figure out what c is because we know the initial velocity of this car is 80 feet per second. So we know that this equals 80 when t equals 0, which means that c equals 80. And we have then the velocity function of -16t plus 80. And let's go one step further and find the position function. So we know that the derivative of the position function equals the velocity function. And therefore, if we take the integral of the velocity function, we'll have the position function. So the position function is going to be the integral of -16t plus 80. So we'll use the power rule, and we'll increase the power by 1 and divide by that new power. And then do the same thing here, and we still get the plus c. So cleaning this up just a tad, we got -8t squared plus 80t plus c. And we know that at the very beginning, our position was 0 feet. So s of 0 equals 0. So we know that this is 0 when t equals 0. Which means that c equals 0 in this case. So we have the position function, s of t equal to -8t squared plus 80t. Now we want to use this idea that we know that when the car has stopped, the velocity is 0. So I'm going to go back to this velocity function right here, and we're going to set this equal to 0 and solve for t. So if we subtract that 80, we will get t equal to 5. So at 5 seconds, the car has a velocity of 0. So if we put this t equals 5 into the position function, we will know how many feet the car traveled over this 5 seconds. Oops. And we will get 200 feet.